Okay, we do need to clarify a couple things on here, mainly for terminology, and there is one small mistake in problem number 3. But what's a major arc? Yeah.
Like 3 points on a circle, more than half the circle with 3 different points.
Stop. More than half the circle. Okay. Now, by more than half the circle, I assume you're referring to the circumference.
Yeah.
Okay. Good. Everybody good on that one? Now, you may have phrased it differently. I saw some people said it's an arc whose measure is greater than 180. Some people said it's an arc that's at least or greater than half of the circumference. There's a lot of different ways to phrase it as long as we understand what we're talking about. So in this particular picture, I asked you to talk about the major arc ARS. Every time we talk about arcs, you don't need to write out major arc. You just need the notation. Notice for the major arc, there's 3 points. That's important. When we're talking about an arc, we are saying, okay, ARS means start at A and go to S. There's 2 ways to do that. Do you see it? I can go clockwise or I can go counterclockwise. If there's only 2 letters, RC for instance, that means go from R to C along the circle as quickly as possible. Go from R to C around the circle as quickly as possible. That gives us a minor arc whose measure is? Less than 180. Good. 3 letters means go from A to S, but pass through R. So we're going to get something that looks like this. Okay, major arc, which satisfies Gavin's definition. It's an arc who's greater than half of the circumference. Okay, the one thing I don't like is, well, let me ask you the question. Why don't I like that? Got it?
Semi-circle could mean like multiple things, I guess.
Yeah.
Like it can mean like semi could mean just half or a certain portion of like or.
If I go from A to C,
Oh wait, no.
which way do I go?
Either way.
Right. Is this a semicircle?
Yeah.
Is this a semicircle?
Yeah.
So which one am I talking about with that?
Just-
Semicircle should be named with 3 points. Okay. A to C, but passing through what point? So either ARC or ASC. Greater than 180, less than 180, equal to 180. Okay. Now the fun part. Different approaches to this problem, but when we talk about an arc, in this case the arc AR, we're going to talk about 2 things. We're going to talk about the arc measure, which in this case is 96. Notice it corresponds to that angle at the center. And we're also going to talk about the arc length, which is more interesting. How long is it from A to R? If you had a circle and you walked along the circle, how far would you walk from A to R? So a lot of groups got the answer. By the way, the answer should be like 6.7, 6.8, something like that. Somebody explain to me where that answer came from. Go ahead, Gavin.
So like all around the circle it should be 300 or like in the I like looked at the middle of the circle where the degrees was, it should be 360.
Mhm.
So I did 96 divided by 360. Yeah, 96 divided by 360 times the circumference, which was
Does that make sense to everybody? Megan, explain it to. Tell us your explanation that you gave me when I was over there before, because you focused on a different point which may help some other people.
I found the circumference first, so I did 2 pi 4, and I got the circumference. And then I did 96 over 360 equals x over 100, so I could get a percent. And then I made the percent equal to the circumference.
Good. So same approach, just a different concept. What she found is what percentage of the circle is that green arc. It's exactly what Gavin did, he just phrased it in a different way. And so for some groups that were struggling, I asked a very simple question. And everybody was able to answer this. If I extended this into a diameter, call this point Q, could you find the length of the arc from A to Q? How? It's half the circle, right? If I drew a different segment in here, or radius I should say, and made that 90 degrees, could you find the length of that arc? How? It's a fourth of the circle. How do we know it's a fourth of the circle? It's 90 over 360. How do we know this is half of the circle? 180 over 360. So when we go back to this, all they're doing is setting up a fraction or a percent of the circle that we're talking about. Does that make sense?
Yep.
Okay. Keep it as simple as possible. If you can find the entire distance around the circle, you should be able to find any portion of it that we're talking about. And how do you find the portion? Well, it comes from this measure in the middle. Okay, let me get rid of this stuff. I have one more question for you. And that is, based off of this same problem, could you, well, I know you could, but how would you find the length of this arc? Okay.
360 minus 96 is that angle measure.
360 minus 96
Yeah. Yeah. And then
is?
is
264.
264.
Right.
And then-
360 minus 100 plus 4.
And then you do the circumference times 264.
Okay? Good. 264 divided by 360 times the circumference. How else could you find the length of that purple arc? Yeah. Wait, hold on. We've heard enough of it. Million.
So you would do what we did earlier and find the distance from A to R.
Uh-huh.
And then you would subtract that distance from the original circumference.
Bingo. I don't know how to write that. You would take the whole circumference minus the squiggly and whatever. Something like that. Any other ideas? Okay, good. Both of those will get you the, well, they should get you the same result. We good? Any problems? Now, the thing to be careful about is the terminology, and I want to make sure everybody's good to go. Do you understand? I mean, I know you understand the difference between what a major arc is and what a minor arc is, but are you comfortable with the notation? Major arcs, 3 letters. Minor arcs, 2 letters. Beautiful. All right. And if you need to add points, if, for instance, I wanted to name this purple thing, I'd have to put a point in here, let's call it X, and talk about the arc AXR. Go from A to R, but pass through X, versus arc AR, which means go from A to R as quickly as possible. Okie doke? Problems? Outstanding. Let me stop this.